Okay, we're live. I see that we have some people joining already. We're going to be here for just a couple of seconds while we wait for everybody to join. Let's see how many people we can gather today. We already have questions that have been sent by email, but you will also be able to ask any questions regarding the topics that we'll cover today in the live stream, or any further topics, anything else that you want to ask regarding the production, the Kickstarter, the shipment of the Kickstarter kits, or the pre-order kits as well. But again, feel free to ask anything that you may need from us. Okay. I see that we have already some people. By the way, you will be seeing me check this side of the screen today. I just have the live chat, so we don't have some of the issues that we encountered on the previous live stream. We're getting professional. Okay, just a bit, just enough. So if you see me looking around over here, just bear in mind that. This is what I'm looking at. Okay. On that note, I think we can start already, if that's okay with you, Bruno.
Yeah, okay. I'm just preparing some examples here. I will show later.
Great. So Bruno over there, as he's saying, he's preparing some examples. So this sets me up in order to let you know that today we'll be covering basically developments. Okay, so new developments that we've been tackling. Some of them have already started back when we finished the Kickstarter process, okay? And some others also go as far as the beta testing stages that we went through. We did 2 beta testings, if I'm not mistaken, 2018 and 2019. Correct me if you have those dates with you, Bruno. I'm not 100%.
I'm sincerely don't have the data. You're the one.
But just to let you know that it was long ago when we started doing some of the developments that we will mention today. Okay, at least some years back when Chordata was just a junk project. So I see some people joining already. So what we'll be covering today again is developments. Okay, we're gonna have 2 parts. We're gonna talk about 2 main developments that we're tackling right now. One of them is pretty. By the way, guys, if anybody or gals, if anybody has any issues, if you see anything's going wrong with the audio. If there's something you cannot hear, just let me know on the chat, okay? I mentioned this at the beginning of the transmission. I'll just mention it again briefly. If you see me looking this way, it's because I'm looking at the chat, okay? So I'm looking for the comments that you guys may have sent. So again, we'll be dividing the transmission today in 2 stages. We're going to talk about a quick development that's easy to figure out, no matter your level of involvement with the project. The second part is going to be software heavy. Okay, so we're going to see some examples, if I'm correct, Bruno, of code, part of the code base that we work in our repos. So if that part is just not your cup of tea, feel free to leave us by then. You can always leave your questions in the chat, and we'll tackle them in the Q&A, and we'll always forward you the recording after we finish uploading it to YouTube, and it will also be available on Twitch. I don't know how many days though. It's available like 15 days or something, I guess. It remains on Twitch for those that want to see it, that prefer to use that platform. Okay, on that note, I think we can tackle the subjects. Again, right now I'll be looking here. If you send anything through the chat from now on and until the end, we're going to have a Q&A section at the end of the transmission. If you send anything, we're not going to be able to see it until the end, okay? But feel free to send your questions through the chat, and we'll tackle them. We already have some that have been sent by email, but we'll also obviously review everything that you want to ask through the chat room, okay? So in terms of developments, we wanted to review this because all of the developments that we'll cover today have been things that have come up thanks to users in our forum. Okay, this is a good point to mention that Chordata Motion's forums are free to join. Okay, so anybody can join our forum. If you guys are trying to self-build Chordata, if you want any help from our development team, Bruno is always over there in the chat, tackling questions that people may have. So the forums are a really good resource. Sometimes even it's more up to date because it's live with whatever is happening when compared to the wiki. Okay, the wiki we need to do a lot of efforts in order to update it, obviously. But the forums, it's a great tool in the sense that it's up to date with everything that has been happening. It's more of a chaos because obviously there are lots of rooms and everybody's speaking about different subjects. So it's not as organized as the wiki could be, but it's a great resource. Don't forget to join there if you have any questions regarding Chordata Motion. By the way, the forums are live in chordata.cc /forum. Okay, simple URL. We don't hear you, Bruno, for some reason.
Sorry, it says forum.chordata.cc.
There you go. So thanks for the correction. So on that note, one of the main users that we've had in the forum, and it's also a good way to render him an homage right now as we speak, because he has been one of the most active users since the first beta testing, which, if I'm remembering my dates correctly, but he can correct me if he happens to be over here in the chat, was 2018. His nickname, I wouldn't mention his name just for privacy reasons, but if he wants to let you guys know his name over the chat, he can do that by himself. His nickname, he goes by the name of Axon Spark in our forums. And Axon was kind enough to send us pretty detailed reports on the issues he was encountering. Obviously, he was working with the first beta testing kit, so the roughest version of Chordata that anybody could have at that point, basically. We saw rougher during the development process, but it was as rough as it could get for someone else outside of Chordata Motion's team. Okay, let's keep it that way. So he encountered some issues, mainly having to do with interferences that may have come up during the calibration process. Okay, so on that note, since I'm not as tech savvy as Bruno over here would be, I would like to jump to you, Bruno, because maybe you can explain a little bit of how we're going to solve this and how we're working to solve this out by improving our calibration system. If I'm not mistaken, if I got it right, what we're doing right now is basically we're developing a different calibration system, which will have a sort of two-sided type of calibration that will one of them will be optional and will allow us to bypass some of the magnetic interferences that some of the users from the beta testing were having. Is that correct?
Yeah, that's correct. In order to explain a little what this new calibration algorithm that we are developing, I would like to say a few words about this calibration, because actually there are two types of calibration in motion capture. One is the one that you make with the sensor, with the individual sensor, which is normally done once in a while, or just the moment that you build or receive the sensor, you have to do a calibration. But what we're speaking here particularly is, I will look here, is it's called in-post calibration. It's a calibration that you have to do every time you start a new session, and you normally, if you can see videos of Chordata users or another inertial mockup systems, you will see the person, the performer standing in T-pose or M-pose or something like that. This is what we are speaking, this type of calibration is what we're speaking right now. And what happens in this calibration is that the raw data that's coming from the sensor gets mapped to the avatar, to the 3D avatar. So let me show you a couple of examples. This is the one from Axon Spark, but I just find out another photo that will help me illustrate this concept. This is from a new user, QSky, who's building together with some pals the system. I think they're in China, if I'm correct. But yeah, this is a great example of what happens if you don't have a calibration at all. You put the raw data coming from the sensors to a 3D avatar, and the avatar gets completely messed up. And yeah, so you need a calibration, in-post calibration in order to do mockup. So when the project started, this was one of the first things this was a personal project in the beginnings, and I was looking for several algorithms here and there in order to put them all together and come out with a complete mockup.
By the way, Bruno, just let me interrupt you for a second. We're not seeing. I don't know if you meant to show something on the screen. Yeah.
I wasn't sharing the screen. Okay. Here it goes. Thank you, Juanjo. This is the example I was talking about from Cube Sky. You see all the body completely mangled up. This is because the sensor data is applying directly to the avatar before the calibration. So I was saying this is what you get if you don't have a post calibration at all. And where was I? I was talking about, this was one of the first things I was looking for in the beginning. And there is non-free open post calibration available. This is something that we are planning to fix. It's like with this new calibration that we are developing, we will publish a completely open post calibration algorithm, which we think is kind of a great contribution for the mockup community in general. So yeah. There wasn't one available, and what I did in the beginning was implement a simple calibration method, which during part of the calibration process uses the magnetometer as a way to figure out the heading direction of the sensors. So, and this method might work well in some situations, but if you have a little magnetic disturbance in the environment where you are calibrating, you might see this small disturbance multiplied when you actually make the capture. I don't know if you're getting the concept here. You do the calibration. If the calibration is done in a magnetically disturbed environment, this error, which is introduced in the calibration, is then applied to the whole capture session, and you might get some things like this. This is a video that Axon Spark sent us. He sent us a lot of video and a lot of feedback. So again, a lot of thank you to Axon Spark for being such an active and a clean, having this type of straightforward communication with us. So let me show you this example. What he was complaining of, he was showing us, he was referring to this problem as the knee bending in the wrong direction issue. As you can see, let me see if when he raises one of the knees, here it goes. I've started to pause the video, but instead with full screen. I don't know if you see that the knee is bending not straight ahead, but slightly to a side. This is, I don't know why he was having such a noticeable defects in the legs. But it was something that he encountered repeatedly. But it was probably due to a magnetic disturbance during the calibration. And this was something that we tried to work together with him, and we wasn't able to solve it for a long time. So yeah, we were sure that we needed a different calibration process. And yeah, we were developing this during the past months, and we have great results that I would like to show you now. So here you have a Blender scene with two avatars. One has a sample procedure, like movement procedures applied with the new calibration, which is the one in the left. And you have, as a comparison, the old calibration in the right. And as you can see, if I take a look, for example, we make just a quick path through the complete procedure. And then I will go back and show you in particular some of the defects that were corrected with this calibration. For example, take a look at the arms. When the subject raises the arms. This is probably not noticeable from here, but if you go up, we get to see that with the old calibration, since it was using the magnetometer, the heading normally gets disturbed, and you end up with these arms bending slightly to a side. That this was exactly the same that was happening to Action Spark in the videos for the knees. Another, I don't know if you get to see, they are also, the new calibration gets a much more composed, straight pose, and it is also not particularly noticeable when the performer makes this movement. I don't know if you see, but the new calibration is giving us much better results. And I take a look at how the old calibration was given during this phase. Another, let me show you for here. I will just play this walk cycle. I don't know if you see that the new calibration is also giving much greater stable results than the old one. So yeah, we're quite happy with this new development. This is already working as an offline process, but we are currently working on adding it to the Blender add-on, and then to the other parts of the framework that we will show you later during these live streams. Okay. So.
Great. So it's a pretty good point, by the way, also to thank everybody, not only Action Spark, but everybody that joined the beta testing stage, because they were encountering this type of issues that you encounter with the beta set. I know everybody was informed about what they were getting, but still, just having people that are able to join and support a project at that stage, those early adopters that join us and that are free to talk to us, that give us their time and that give us their also their trust by acquiring this type of systems. They have been everything to us for the first few years of the project, so I want to thank them, and also let them know that obviously they will always be taken care of as the first testers of the kits that they were. They will always be regarded within Chordata as the first users that managed to jump into the project at a stage where nobody wants to jump in. So a huge shout out to all of the beta testers. And on that note, I think we can get to the heaviest part. Okay, so this is the part that I meant when I was talking about how we will structure the transmission today at the beginning, mentioning that we're gonna have just a tiny bit of code being shown. Okay, so if that bothers you, or if you're not interested, feel free to jump out and leave us your questions in the chat, or send it through the email if you want to. We'll be checking the chat questions and the email questions as well once we go to the Q&A, which will be the last bit of our transmission today. But on that note, I wanted to mention also another user, and this is an interesting use case because right now we will be talking about a user that's not acquiring Chordata Motion. Okay, so he's intending to use our software base or part of our software base for a completely different project where he wants to develop. If I'm not mistaken, correct me if I'm wrong, Bruno. This username is Mason Safavi. I don't know if that's his name or it's just a nickname, but he was trying to develop a controller. I think it was for flight simulation, but I'm not sure if it was generically for video games. Okay, but basically he was trying to build a controller. Am I right?
Yeah, I remember it was a controller. We have a long conversation. I'm trying to track down what he was exactly building, but I can't find it. But I think it was a controller for a Starship simulator or something like that.
There you go. So something along those lines. Okay, so a controller, and he was building it based on IMU technology, which is the same one that Chordata Motion is based on. Okay. Inertial magnetic technology and sensors that are being used all over the place for different types of uses. So basically he was developing his controller, and his or hers controller. By the way, I think Mason would be a gal over there, but just want to be respectful in that note. He was developing this project, but what he wanted from Chordata was basically a part of our software base. He mainly wanted to use, and afterwards, Bruno, you can correct me if I say anything wrong at this point, but he basically wanted to use a part of the notochord. The notochord is the software that gathers the data from Chordata Motion sensors and sends it to a client, which usually is Blender right now, which is the main integration that we've developed so far. We're working on Unreal Engine, by the way. That's still one of the developments. We're not going to talk about it today, obviously, because it will be too long. But it's on the development schedule. But basically, the notochord is the software base that gathers that sensor data and sends it to the client. Okay, within that program, there's an implementation of the sensor fusion algorithm that Mason wanted to use for his own project. Now, Bruno was kind enough to help him out through the forums. Again, a huge shout out to all of the users in the forum, and just be aware that the forum is live, forum.chordata.cc, if I'm correct with the URL this time, Bruno.
Yeah.
And people, you feel free to join over there and ask for any questions, or ask us to any doubts that you may have regarding how to use Chordata or how to self-build it, anything like that. So Mason was helped by Bruno over here, and we were able to provide him with enough information so that he could use the parts of the software that he needed to use. But right now we wanted to talk about a development that will facilitate this type of tasks. So basically, gathering part or implementing a part of Chordata into another project. Obviously, and this is important to us because we're an open source project, we want people to do this. It's not as in other platforms where they actually restrict this power away from the users. We want to promote this type of stuff, this type of usage, in the sense of just gather Chordata and implement it in as many places as you want, either as our whole software base or just parts of it. So Bruno, you can talk to us about this and new improvements that we've done to the code base, and also, if I'm not mistaken, some Python wrappers and endpoints that will facilitate this type of implementations in the future. Am I right?
Yeah. The idea with this part, we're sharing a particular use case of a particular user that doesn't have much to do what most of Chordata users will be doing. But what's interesting for us of this particular case is a way of showing you some of the advantages of some of the strengths of this type of development, the Chordata framework, which is flexible, is open, and will allow some heavy techie users to do really a particular stuff to integrate the software within different projects. So yeah, let me show you the screen. And as Juancho was speaking, we have this long thread of conversation with Mason Safavi, who was actually doing a completely different stuff. And what he was trying to do was to use what is called, as Juancho said, this will be like a heavy, hardcore, techie part of the live stream. But it's important for us to be able to share this part of the development of this part of the project, which is because it's many of the decisions which are being taken on how to structure, how to architect the whole Chordata framework are targeted on making this platform as flexible and as customizable as possible. Okay, so what we were trying to do again was to, as Juancho said, do this controller using an IMU, which is the same technology that we use. And in order to do that, what the first piece of software that you need is what is called a sensor fusion algorithm, which is a piece of code, a heavy mathematical piece of code, which then fuses the data from the three sensors together and gives you an absolute orientation in space. And that is what we are seeing now, example that Mason sent in the forum, because he was like trying to get an algorithm from somewhere in the web. He tried ARS, then he tried a very similar sensor fusion algorithm, which is offered by Adafruit, which also has several great libraries. And yeah, he wasn't able to make that work because it's kind of a complex topic. And yeah, we went through a lot of conversation trying to adapt our code base or Adafruit's code base to what he was trying to do. Of course, all this, let me show you some of the code. We will start to dig deeper into a really complex stuff. What I'm showing you now is the raw implementation of this sensor fusion algorithm, which is not ours. It was first published by a semiconductor company, which was called Freescale, which was then purchased by NXP, which is the current owner or the current publisher of this piece of code. And this is a sensor fusion algorithm written in C, so it's quite an efficient algorithm, as most of this type of pieces of code should be, because they will be running microcontrollers, which are not very powerful. So yeah, he was trying to adapt this. And adapt this, believe me, is not an easy task. You got a lot to do, a lot to reverse engineer, and yeah. What I was telling to Mason doing this work that we were doing together, or doing this consulting I was giving to him through the forum, was that in parallel, since the beginning of the Kickstarter, we are developing the new Notocore, and the new Notocore is architecture in a completely different way from the previous one. The previous one was a program completely written in C++, and it was a single program which was conceived to be somewhat flexible. You have some parameters through configuration files and through command line arguments that allowed you to customize the way the Notocore was executing. Remember, the Notocore is the program which is running in a Raspberry Pi in the back of the performer, which is hardwired to every sensor, and is the core program of our framework, which is in charge of, as Pancho said, reading the sensors, making the sensor fusion, making a whole lot of stuff, and then sending packages of data to a client. Okay, this is the core of the architecture, and this is what in part makes the framework so flexible. You can send process data to some client. As Sancho said, we are currently using mainly the Blender add-on, but the client are able to be freely created based on some simple API rules, networking API rules. So yeah, going back to a Kalman filter, this project of making the Notocore, transforming the Notocore from a standalone program to a Python module was one of the foundations of one of the ideas, the first ideas when doing the Kickstarter, and it developed during this year, and we are getting some interesting results, and this is something that we thought it would be nice to share with you in this type of streams, because this type of features are normally hard to explain with normal communication ways. Okay, so wrapping up on this, we used to have this sensor fusion algorithm, which was written in C. What we are doing now with the Notocore in many ways is wrapping many of the, I'm sure you code that you will probably don't understand, but you need to see is that we are wrapping pieces of code that come from the C implementation of the Notocore, and which again, C is normally efficient and fast, and Python is not efficient, not even fast, but is really handy to work with. So what it ends up is something that will be used mostly to handle the core aspects of the Chordata framework, as reading the sensor, sending data, but can also be used in a completely different way. For example, Mason here might have been able to use it to create like a really simple controller, software controller for his project. Okay, what I would like to show you here, if some of you understand some Python, is just a simple implementation or a simple use. If let me say this again. If some of you understand some Python and some of you are interested in this type of processing of the sensors, you might be able to see that these 60 lines of code are something quite simple for what you normally have to do to get a MAU sensor working, okay? So what you can do is import in any platform. I'm just running in my computer, which is not even a microcontroller, it's just a regular computer running Python. You can import some of the type in the Notocall module as the Kalman type. You get some complex mathematical primitives, which you are able to declare. You can feed some of the values, which in this case are not coming from a sensor, are just coming from a CSV. This is something that we do a lot during development. It's like are not constantly using the sensor. We just record some of the data of the sensor in a CSV file and then use it over and over again to iterate in the different developments that we do. And yeah, you are able to feed that into the Kalman filter. And then in this case, I was just trying to get the calibration values for one of the sensors. And since I got there, let me just run it for you. I don't know if for any of you this will mean a lot, but you will see that running.
And the terminal always looks cool.
Yeah. The terminal always looks cool, and let's just hope it starts working.
If it works, it looks cool. Yeah.
No, here it is. So yeah, at the end of the day, what you got is just a couple of values, but this is what we do all day here in Chordata. It's like inputting numbers and getting numbers out. And yeah, this is something quite exciting if you are into, again, trying to handle MAU data or trying to handle several topics. Like we use this Kalman filter as an example because it was something that it wasn't there. We didn't know of a Python wrapping of this, as I say, already well-known algorithm that is in the wild over there for some years. So yeah, this is the hardcore stuff, the hardcore part of the stream. I hope for many of you it wasn't so heavy. We are wrapping up now, Pancho.
Yeah. So basically, on that note, we cannot get any higher than this notes over here. So yeah. So everybody joining us at this point, basically, it's interesting that you could show what we do every single day. You know what sometimes those numbers are magical, and sometimes they just make you bang your head against the table. But yeah,
it was also a way of showing all you guys what we are up to like every day. It's like this is what we are doing, and for us it's quite normal to these numbers, and we just wanted to make you part of all this.
If you don't code, it's hard to explain why this is fun and why will someone get to this and work on that for 4 years. But yeah, hopefully you'll get us. Hopefully you'll have our same sense of humor in this sense. So guys and gals and everybody joining us, if there's any question, this will be the point where you can ask it. If there are none, I already have some one that was sent through the email. But if you want to send us your questions, right now we're looking at the chat. Remember, feel free to ask us any question. As you've seen, we're showing our software base, so we cannot go any more open than this. So whatever question you need us to tackle regarding the production process, the Kickstarter, the deliveries, how everything will work, just let us know right now. This is your time. And I will also jump to one of our, I think I don't remember at this point, sorry for this, Alex. I won't say his last name just out of sheer privacy. But Alex is either a Kickstarter user or a pre-order user that acquired one of our kits through one of these programs. I think, if I'm not mistaken, he is from the pre-order cohort. Okay, so what he's asking, so obviously we're all Blender lovers over here. We hope you share this love for this amazing 3D platform with us. And Alex is already asking, since Blender has announced has announced and is it already released, Bruno? You're more up to date on this, Blender 3.0?
I have to say, it was about to be released. I am a great Blender fan, but I don't really know if it was already released or not. I will tell you right away.
Yeah, and we're pretty we're two fans of this platform, so it's pretty pretty early. So if this happened, it happened like in the past few days.
Yeah, it is already released. Okay.
Great. Kickstarter, it's. Okay, someone sends me a message. Correct, Kickstarter is already released. Hopefully I didn't say it wrong. I meant to say Blender, but if I said the Kickstarter, obviously it's not. I was I was wrong. But no, I meant Blender. I meant Blender 3.0, the new platform. Oh, hello Alex over there. We have you joining us. So yeah. So so in that sense, Alex, I'm guessing that you meant to say that Blender is already released, not the Kickstarter. Hopefully, I was I was overbreeding over here, thinking that I said the Kickstarter was already released. It's not released, but Blender 3.0, if Alex over here is meaning this, is already released. And what he's asking is whether we're already working on support for the 3.0 version of Blender. If I'm not mistaken, Bruno, this version shouldn't generate that many conflicts with the current plugin that we have, but you can correct me if I'm wrong on that one.
Yeah, let me show you. This is, I was looking at this just before starting the live stream. Theoretically, the breaking changes in the Python API for the new Blender 2.0 version are not big, so there should not be any change to be done in the add-on. We will for sure test it, but if any in the community, you Alex or someone wants to test the current add-on in the new version and just give you some feedback in the forum or somewhere, it will be a great hand for a BC development team. So, but yeah, what I can get from here and is that there are not big breaking changes in the API, so everything should work correctly.
Yeah. So if everything works as it says, and it not always is the case. So usually when we try to test up, by the way, Bruno, if you want to stop sharing the screen. So if everything works as mentioned over here, as Bruno was saying, we shouldn't have any conflicts with Blender. So you can rest assured, Alex, that at least the plugins should work right off the bat with Blender 3.0. It's not in that sense as heavy of a release as we encountered with the 2.8 version, I think, that we had all those big changes.
Yeah, there was a big break in the Python API. Yeah. It was a complete restructure of the whole Blender application.
There you go. Yeah. So it shouldn't be as heavy as that. Okay. Obviously, that can be minor inconveniences, but our great and interested development team is always happy to tackle those, and we'll do our best to solve them as fast as possible. Okay, Alex, so with that, I think we've tackled your question. I see no further questions on the chat. If anybody wants to ask any questions, this is your time. If there's nothing else, I think we can wrap it up for today. But before we do that, okay, if you want to send any questions, I'll just do some announcements. And we can go after that or answer any final questions you may have. So I forgot to mention at the beginning, great news regarding the production process. The provider that we mentioned, the provider of the sensor that we mentioned in our previous live stream, has confirmed the intention. Okay, this is important to say because this thing is pretty crazy right now. You know, this market's pretty crazy. It looks more like a Wall Street type of investment.
Or Far West.
There you go. Or the Far West. Or the Far West. Maybe a better metaphor to describe it. So the provider has confirmed the intention to deliver in the first semester of next year. So all the information we provided in the previous live stream is maintained as of right now. We'll always try to inform you at the beginning of this live streams on how this process is going until we have everything and we can ship it to you, obviously. But we'll obviously, one of the main purposes of this live streams is to keep you up to date. They started because of this. We'll do a lot of things afterwards with this new platform that we've started working with. But it's also great to update you on that and to let you know that as of today, everything seems like everything will run smoothly, at least with the minor delays. The important delays that we had for the Kickstarter deliveries. Okay. Also, on that note, the next live stream will be on January. We're probably gonna move it more towards the end of the month for next month, just because the beginning of the year will be pretty heavy in terms of different tasks that we have to tackle. We're gonna move it more towards the end of the month. We don't have quite defined the subject yet. We're thinking of different things that will be interesting. We also want to cover things regarding the DIY versions of Chordata, how you can work them out. Okay, we'll announce the final subject that we'll be tackling in our next live stream through our social media. So make sure to stay in touch, and in order to check first of all the date for the next live stream, and also the subject, just to check out if you're interested and you want to join us. We'll always be glad for you to join us in over here in this live streams. Okay. So on that note, I see no further questions on the chat. So I think, Bruno, we can wrap it up for today. And you can get to those numbers on the terminal and see if they work out.